Hey everyone, welcome to Code Harmony. Today we are going to solve a very interesting question, LeetCode 2348. Why this question is interesting? Because this question has been asked in Google, Meta, Amazon in their coding interviews. And this question is based on subarray, which is a very easy to understand concept. किसी भी array का portion is subarray. A portion within an array, contiguous portion is subarray. Simple, pretty simple. Now let's have a look at the problem statement. The problem name is number of zero filled subarrays. And here in the problem statement, they are saying we are given an integer array nums. So this is something given to us and written the number of subarrays filled with 0. This is we have to return. And just a definition of subarray, contiguous non-empty sequence of elements within an array. Okay, so the problem statement is pretty simple. Given an integer array nums, return the number of subarray filled with 0. And we'll also have a look at the constraints. Constraints are length will go till 10 to the power 5 and the number in that array can be negative 10 to the power 9 to 10 to the power 9. Okay. Now let's try to see how we are going to solve. First of all, this is given to us, an integer array, and what we have to return is number of subarrays where all the elements are 0. I will try to keep the explanation beginner friendly. So whoever is getting started with their journey on LeetCode, don't worry about this medium tag. It's an easy problem if you understand the concept, which is subarray, and concept itself very easy. So what is a subarray? First of all, they have also given the definition. I don't like this definition. I will say that subarray within an array is a portion. If I pick this portion, pick a piece out of that array, that is a subarray. And this portion will belong from I to j. And these two are two valid indices of array. So I and j are two valid indices. If they are valid indices, they will definitely belong to this 0 to n minus 1. Let me write something like this, 0 to n minus 1, both inclusive. So they are valid indices. And subarray is something starting from this, ending at some other index, or maybe ending at the same index. This 3 to 3 is also a subarray, and 3 to this 0 is also a subarray, and this 0 to 0 is also a subarray. So I should be less than equal to j. J can be equal to I, or j can be greater than I. So if I combine these two equations, it is something like this: I to j, where j is greater than equal to I and less than equal to n. Less than n, less than equal to n minus 1. Simple. Greater than equal to 0. So what is this definition of subarray? If this is the definition of subarray, why not I just check all the subarrays in the given array? If I check all the subarrays and see whether all the elements are 0 or not, it's pretty simple. So if I write this template in terms of code, for I will go from 0 to n minus 1. And for j will go from I to n minus 1. And by writing these two loops, I know that from I to j, I have this subarray. I know what are all the subarrays. So this loop is order of n time, and this loop is order of n time. And here I will get all the subarrays. Now whatever you want to do with this subarray, you can do that. If you want the sum of that subarray, sum of all the subarrays, you have sum of all the subarrays. You want to know the average of every single subarray, you have that. If you want to print every single subarray, you can print that. You can do whatever is required. Here in this case, we require all the subarrays where every single item is 0. So one thing is using this template, order of n square time, to check every single subarray, to get every single subarray. And then after that, if we try to check whether all the elements are 0, then it might require some other loop, right? If we are checking in an explicit loop that I just k equal to I to j, k is from I to j, and we will see whether all the elements are 0 or not. It might require some other loop. It means that overall it is going order of n cube time, but this is not required. When we are already iterating over the second loop, when we are already going over the second loop, we can check if it is 0. If we keep on getting 0, we will keep on expanding the second array, second position, right? It means, let's say when I'm starting with 1, 1 itself is not 0, so there is no need to go further. 3 to 3 is not 0. 0 to 0, so this 0 to 0 is one subarray, and then this 0 to another 0 is also subarray, and then again if we are getting 2, then that is not a subarray. Okay, I will explain it further by doing the dry run. So by using another loop, it is not recommended, because that is like super brute force. So instead of that, what I can do is I can use a concept which is known as running sum. Running sum. So we got started with array. What is an array? Array is just, you should already be knowing. Then subarray, a piece within that array, and in that subarray template, we applied running sum. Running sum means when you are running over a subarray, just process whatever is required. Let's say if I ask you to print every single subarray sum, and the subarray is 1, 2, 3. So first subarray is 1, then another subarray starting with 2, starting with 1 is 1, 2, then 1, 2, 3, then 2, 2, 3, then 3. There are 3 subarrays starting with 1. There are 2 subarrays starting with this 2. 1 subarray starting with 1. So if I ask you what are the total number of subarrays, then array size is 3 and it is equal to 3 plus 2 plus 1. What is this 3 plus 2 plus 1? This is sum of first and natural number. So if my array is of size n, the number of subarrays is equal to n into n plus 1 by 2. Why we are discussing this formula? Because this formula will be used in the next approach where we will try to optimize it. So this is also a concept, how many subarrays we form given the array size is n. This is itself, you can also call it a math topic. In the mathematics section in arrays, when you try to understand mathematics in the array chapter, you will also see a formula that sum of first and natural number. What is that? N into n plus 1 by 2. This itself is a whole topic. Okay, so now by running sum, what does running sum mean? If my array is something like this, 1, 0, 0, then if I check every single subarray starting with index 0, then there is no subarray I need to capture. Okay, ignore it. So this is for I, this is for j. So next, increment the I. Now I want to check every single subarray starting with I equal to 1. I equal to 1, j equal to 1, the subarray is valid. I equal to 1, j equal to 2, this is also valid. So 2 subarrays are there. Now I will check all the subarrays starting with index equal to 2. Index I equal to 2, 2, j equal to 2 is valid subarray with all the elements are 0. So in short, the portion are this portion and this portion and this portion. These 3 subarrays will contribute to my answer. So for this 100, the answer is 3. And now what is the answer for this array? This array, the answer is 1. This portion is going to contribute to the answer 1, 0, 0, 0, and this 0. And this portion also going to contribute to the answer 0, then 0, 0, then 0. 3 plus 3, which is 6. 6 subarray we are going to get, right? And this is something by using the subarray template with running sum. Running sum, it means we are able to do it in order of n square time. So this is something pretty easy to implement, and you guys can try it by your own. But according to the constraints are making us bound to keep it in linear time or better time than n square time. So 10 to the power 5 into 10 to the power 5, if we keep it in the worst case, will give us TLE. So now we'll try to do it in a linear fashion. So this is the optimized approach now. And in the optimized approach, let's say 1, 2, 0, 0, 1. In this array, we want every single subarray where all the elements are 0. So we are we can say, in other terms, we can say that pick this portion, and whatever is the subarray of this portion, those are going to contribute to our answer. If I'm picking this portion, why I'm picking this portion? Because all the zeros are contiguous, all the zeros are together. If I'm picking this portion, this array is of size 2, and I'm 100% sure that every single subarray of this array is going to contribute to my answer. And two size array have how many subarrays? 3 size array was having n into n plus 1 by 2 subarrays. So it is 2 size. So it is going to have 2 into 2 plus 1 divided by 2, which is 3 subarrays. Correct? So if I know how many times this contiguous zero is coming, I can directly say how many valid subarrays I can form. So this is something using math topic, which is sum of first and natural numbers. Now if my array is something like this, 1 0 0 1 0 0 and 1. In this array, this is one portion. Okay, this portion is going to give me 2 into 2 plus 1 by 2 subarrays to my answer. And now next portion is this. This is also going to give me 2 into 2 plus 1 divided by 2. These many subarrays are valid. Instead of that, if it was something like this, 0 0 0 0 1. If this was the array, then what is the portion? What is the subarray where all the elements are 0? 4. 4 is the length of that portion. So 4 into 4 plus 1 divided by 2. Simple. Now my problem statement is reduced to finding that block. Finding this is one block, this is one block, and this is one block. Finding that block in order of n time, like in a linear time. Finding that block. कि वो block कितने size का है. Here the size is 2. Here the size is 2. And overall it is this. Just applying the math formula. So 1, 2, 0, 0, 1 and 0. Okay. This is my array. And here nums array. Here I want to find that block. Is this that block? I'm starting with this. No, the this is not the part of the block. When I'm moving ahead, it is 2. When I'm moving ahead, oh, I am encountering first block. First block size is now 1. Then I'm moving ahead. Okay, this block size is now 2. When I'm moving ahead, now it is not 0. It means that I am done with this block. I just visited a block, and I visited a block of size 2. Then directly capture it to the answer. N into n plus 1 by 2 plus equal to. And I have captured it. Then next block size is 0. Then I'm moving ahead, and this is the block size. Block size is 1, and I'm moving ahead. When I'm coming out, it is done. But there might be the chances that in the last position there is some block. That should also be added. 1 into 1 plus 1 by 2. That is 1. So this is 3 plus 1. 4 is the answer. This is something we need to do. We need to iterate over the array to check whether there is a current block, and if this block is over at this position, capture the answer. And now this block is there, and now capture it explicitly after the end of your iteration. So iterate over the array in order of n time, and whatever is the block size you just discovered, you can add it to the answer, because every single subarray of this block is going to contribute to our answer. And see, if they are saying that print every single subarray, printing is something else, but they are asking just number. Just let me know the number of subarrays. And number of subarray we have already discussed that is equal to sum of first and natural number. And the formula to first and natural number is n into n plus 1 by 2. So this is what we are doing. So here we started with subarrays topic, and then we went to a iteration, or you can say running some type of logic, running some plus the mathematic formula, that sum of first and natural number. This is something we have to do. Okay, now how do we code it? इसको कोड करने के लिए 1 0 0 1 0 0. Let's say this is my nums array, and let's say I am keeping a variable z which is 0, and z means current size of a portion where every single item is 0, and I'm iterating over it. Let's try to iterate over it. It will be pretty simple. I will start my iteration from 0 to n minus 1. When I'm at 0, I will check whether this is 0 or not. If it is 0, so first of all I will be iterating over this block 0 to n minus 1, and then I will check whether the current element at 0 is equal to 0. If it is 0, then my current block size is increased z plus plus. Else, if it is non-zero, what I will do? It means that if it is non-zero, whatever is my current block size, which is just ended means at this moment my current block size is 0. But when I'm going ahead, coming here, when I'm coming here, the block size is 1, the block size is 2. When coming here at this second time 1, then my block size will be 2, and that I have to capture in the answer. So answer plus equal to block size is z into z plus 1 by 2. And now as I have used this block is no longer required. Make z equal to 0. Okay, this is fine. So this is the for loop we have to use, and after this for loop there might be chances that this z is also non-zero after this block size. How? We will do the dry run with the code snippet we have covered so far. Initially z is 0, then we don't have a block. When the z is becoming 1 0 1 2 3 4 5, now z, when I is becoming 1, here it is 0. If it is 0, increase the z will become 1. 0 size block will become of 1 size. When I'm coming ahead, it is 0, z will be incremented to 2. When I'm going ahead, it is 1, it is non-zero. It means capture the answer. Answer is 2 into 2 plus 1 divided by 2, which is 3. So answer is 3, and z will become 0 again. Now next, z will become 1. At this moment, z will become 2. At this moment, my iteration is over. But I have included the effect of this block, but I have not included the effect of second block. So second block will also be included. So answer plus equal to z into z plus 1 by 2. Now you might wonder, what if the block is of 0 size? If it is 0 size, answer will be incremented by 0, and in the end return answer. So this is my code. I initialized with 0 and then iterated over the array. I checked if it is 0 or not. If it is 0 block is incremented. Otherwise, if it is non-zero, it means whatever is the 0 block we have captured so far, if it can be of 0 size. If it is of 0 size, no need to do anything. If it is non-zero, just take the effect into picture and make it 0. After the end, there might be chances that where there is one block at the end. So this is the complete code. And here, if we try to have a look on time and space complexity, what is the complexity for this formula? This formula is order of 1 time. And this iteration over the array, iteration is order of n time, and this formula is order of 1 time. But the integer value will go till 10 power 5. So there are chances that this value might overflow. So make sure that you are keeping it in long. That's all about the approach, and let's write the code, same code, and see if it is. First of all, I'm keeping a variable z to capture the current 0 size block, and then I will be iterating over the given array for I equal to 0, I less than nums dot length, and then I plus plus. I will iterate over it. If the current element is nums.I is equal to 0. If the current element is 0, just directly increase the size of C. Otherwise, if it is non-zero, then whatever is my current block that I have captured so far will contribute to my answer. My answer will get incremented by something which is z into z plus 1 divided by 2. After that, just move ahead. Now z we have used, and next time it will be incremented again from 0. At the end, we just have to return answer. What is this answer? Long value we have to return, and answer is a long variable 0 L, and here we also need to take it long, so I'm converting it to long. So this is a long value and this goes 0, and let's see if it is working fine or not. Running on sample test cases. Sample test cases are failed. Why? Because this first block we have taken into picture, but what about the last one? Last one, this is not captured. So just take this problem statement, take this instruction, and keep this instruction in the end as well, because there might be the chances that at the end there is one block. Now it will submit successfully. Let me submit it directly. It got submitted successfully. I hope you understood the approach, and it was a good beginner friendly problem, as well as good to understand some basic concepts. In case you get any doubt, just do comment down below or discuss in the Discord community. And thanks for watching. Bye bye.